That will lead to switching noise at those frequencies that will likely lead to signal integrity and possibly EMI problems. We'll discuss this more as we go. I'm not done talking about this subject. So what qualities have the greatest impact on power ground plane inductance? Is it copper thickness? Is it plane size? Or is it spacing between planes, dielectric thickness? Plane size has an impact, as you will see later. Copper thickness has almost no impact unless you're dealing with really low frequency switching with a lot of current. Then copper thickness will matter, but only if it's really low frequency where you're drawing amps of current. That's the only place where copper thickness would matter. At high frequencies, skin effect takes over, and at high frequencies and high current, the copper of the plane, anything beyond half-ounce copper, is probably of no value. Anyway, so what matters most? It's dielectric thickness. This shows examples of dielectric thickness. This is a study done by Sun Microsystems, and it shows examples of dielectric thickness of 2 mils, which is 50 microns, 4 mils, it's 100 microns, 8 mils, 16 mils, and 50 mils, which is 1.125 millimeters roughly. You can see the inductance per square. Per square? Per square what? Yes, per square. Per square millimeter, per square centimeter, per square inch, per square yard. It's per square. It's just like resistance. It is a per square measurement. I said a minute ago that plane size matters because I really shouldn't have even brought that up. I will really answer that in a little while. But if you have a large enough plane area to form a square area around power and ground pins on the IC, then the combination of all of those will determine the inductance of the planes based on the overall squares and their overlaying properties. In other words, whether it's a square inch or a square millimeter, planes at 2 mils separation have about 65 picohenries of inductance. And it isn't just true of square planes. If you have a circular area that's very small, it will have a fixed inductance. If you keep a circular area but make it 100 times larger, where it has a several inch or many millimeter diameter, then it'll still have the same inductance as it did as a small circle. A constant shape, when it